Now what we haven't seen, which are the compound pulley systems or block and tackle systems. These are a combination of fixed and movable pulleys. And what happens here that the more pulleys there are, the less force we need to lift the load. It is going to be very important to take a look if we have fixed or movable pulleys, because the system is going to behave different. We can have many dispositions of the pulleys, and we're going to see them. So we're going to see now the horizontal system. In this case, as you can see, we have the pulleys placed horizontally. This has this direction because the rope is being pulled from here, so this pulley goes the other way around, and now it again changes direction, and this one goes this way. So as you can see, this goes counterclockwise, this goes counterclockwise, and this is the same case. So it changes direction in its pulley. Now let's see which of them are fixed or movable. In this case, this one is fixed. It is directly attached to the roof. Also happens with this one, but these ones also move up, so they are movable. Okay. Now let's see the forces and the resistance. In this case, we have this resistance, and what happens to this? This resistance is going to be shared between the different parts of the rope. If you remember, the movable pulley, the one we've just seen, divides the force between the part of the rope that is attached to the roof and the part of the rope we have to pull. In this case, happens just the same, but we have two movable pulleys, so this force is going to be divided into 4 parts: 1, 2, 3, and 4. And that's what we have. What happens with the fixed pulleys? They don't reduce the force they have as input. So the final force, this one, is going to be exactly like this one. Okay, remember this is like the fixed pulley we've seen. So this is what we have. The force is equal to the resistance divided by 2 times N. And what is N? N is the number of movable pulleys. So for each movable pulley, the force is going to be divided by 2. And that's what we have here. What happens with the distance? If you remember the equation, I'm going to put it here again. This first equation, okay, this one, we are going to take always the distance and calculate it from the force in all the cases we are going to see. So in this case, this is what we have. Yes, so the distance we have to pull, this is going to be 2 times the number of movable pulleys times the height we want to lift. That's it. Okay. Let's move to the vertical system. This is exactly the same. This is exactly the same, but the disposition looks a bit more complicated. It's a bit more difficult to determine where are the fixed pulleys and the movable pulleys. But we can do this very easily. First of all, we're going to analyze the forces. We have here the resistance, and here the force we make to lift the load. Now, this is going to be the direction of the pulling, because we pull the rope from here, and now follow the rope. This is where it goes, so this is going to be lifted. Okay, this is going to be lifted, so the pulley moves this way. Okay, this is exactly the same. Now, this way, what happens with this? This is going to be pulled from here, so this is going to move that way, clockwise. And this pulley pulls from this part of the rope, so this one is going to be moved this way. Okay, so difference from the horizontal system. All of the pulleys move to the same direction, rotate in the same direction. Now, let's analyze which of them are fixed and which of them are movable. In this case, this is the easiest one, because it's the one we can see that is attached to the roof. But look at this. This one is attached to the fixed one, to a fixed pulley through this part, so not with the rope. So this is also a fixed pulley. This one is not going to be moved. What about the rest? They are movable. Take a look at this. When we pull from here, this one is going to be pulled also with this part of the rope. This is not attached to any fixed part. And if this is going to move up, this will move up too. So these are movable pulleys, both of them. Okay, the two of them are going to be lifted. So we have two fixed pulleys and two movable pulleys. Same case as the horizontal system. F, the force, is going to be equal to the resistance divided by 2 times N, being N the number of movable pulleys, in this case 2. And we calculate the distance with the equation we've seen.